Hi class, how are you today? I think it's about a 2/3 chance that's great! The learning target for today is to use ratios and proportions to solve problems. For the scale of 3, you can use ratios and proportions to solve problems. 2, you can use ratios and proportions to solve non-word problems, so the word problems give you trouble. 1, you can use ratios and proportions to solve problems if only x is used. We'll have problems that have things like x minus 5, 2x plus 3. So if only x is used, you can do it, but if you have more than just x, you have trouble. And 0, you cannot use ratios and proportions to solve problems. Let's get started. Alright, let's start off with some vocab. First, a ratio. A ratio is a comparison of two quantities by division, and they can be written in different ways. So, one way to write them is by writing a fraction, r over s. Another way you'll often see is with a colon in between them. So, r colon s. Or they'll just say exactly what it stands for, R2s. So it's the ratio from R to S. What is the ratio between them? When you're calculating stuff in math, you usually use this one the most. In the real world, I see this in sports a lot. Also, we'll be dealing with it a lot when we're talking about measurements. You see it like this. But if you just want to write it out in a sentence, you could even see it like this. Next, we'll talk about proportion. A proportion is an equation where two ratios are equal. Hopefully you've seen this a bunch of times before, probably in middle school. So the way to write that is, say you have two ratios. So one will have a ratio from A to B and a ratio from C to D. And those two ratios are equal. So we put an equal sign between them. So it's an equation. Something equals something. So we'll talk about how to solve those in a moment, but this is mostly used to be able to solve for missing measures with similar figures, and we'll be using this a lot this unit. Final vocab word is scale factor. Scale factor is the ratio of two corresponding sides of similar figures. So this is often used in like scale models. So if you've got this really big object and you want to make a scale model of it, you need to make it smaller. But you want to make it proportional. You want everything to be the same ratio. In order to do that, you need a scale factor. So usually, like if you have this really big object, you want a scale factor of, say, like 1 over 20. So it'll be 1/20th the size of the actual object, making it much smaller, but everything's still proportional, so it would still work the same way. Alright, now let's move on to some actual equations. Alright, so there's two ways to solve proportions. I'll start off by showing you one way, and then I'll show you a second way. The second way that I'm going to show you is the way I'm going to use from here on out, because it's the way I find easier, and is usually the method to go about it, especially for more difficult problems. But I'll show you both ways so you have choices of what you want to do. So here you have 7 over 5 equals 28 over x. You've got two fractions. The first method is, if you've got two fractions, you know fractions can be reduced, but they can also go in the opposite direction. So you can say 7b becomes 28 by the same factor that 5 becomes x. So what do you have to multiply 7 by to get 28? The answer for that is 4. So you take 7 over 5, multiplying them both by 4, and that will give you 28 over 20. So that means your x is 20. So x equals 20. It'll be a bit more difficult to do that later on, especially if you're dealing with problems where the factors are not necessarily whole numbers. Because if the scale factor is, say, 3.5, that would be a lot harder to figure out what it is. And that's why this next method works similarly all the time. It's the same difficulty pretty much no matter what the problem is. So 7 over 5 equals 28 over x. Same problem. We're going to do a different method. Whenever people see fractions and want to multiply, they usually say, cross multiply. That's usually wrong. When you're multiplying fractions, you don't. But when there is an equal sign in between two fractions, this is where you cross multiply. So if you were to cross multiply these two fractions, you say 7 times x equals 28 times 5. So 7 times x, or 7x, equals 28 times 5, which is 140. Then solve for x. Divide both sides by 7, and that'll give you x equals 20. Both ways you get the same answer. One is easier during the easy kinds of problems, but one is easier during the more difficult problems. Make sure you understand how to do both of them, though. Alright, now let's look at this problem. And as I said, I'm going with the second method, the cross-multiplying method, also known as the cross-product method. So, from here, we want to cross-multiply. So start off with x plus 2 times 2. We have to multiply all of x plus 2 times 2. So if you remember back from Algebra 1, if you multiply a whole expression by a number, you have to use what's called the distributive property. So we would write this 2 times, in parentheses, x plus 2. So we're multiplying the 2 by all of x plus 2. And then on the right side, we have 4 times 6. So that's where we get the cross multiplying from. Then, so to use the distributive property, we have to say 2 times x is 2x, and 2 times 2 is 4, so plus 4. And then on the right side, 4 times 6 is 24. And then solve from there. Subtract 4 from both sides. Gives us 2x equals 20. Divide both sides by 2. And that gives us x equals 10. So just know if we have an expression that's more than just x, you have to use the distributive property. All right, so now let's deal with a couple word problems. First, there are 100 senators in the United States. Write the ratios of senators to states. So we're told that there are 100 senators. 100 senators. And hopefully you know that in the United States there are 50 states. So this is a ratio of 100 to 50. So to reduce this down as much as we can, this would be 2 over 1. Now normally you just want to say 2 to get it down to a whole number, but when you're dealing with ratios, you have to have two numbers. One thing to another thing. So 2 over 1, or you could write it 2 to 1, or in words 2 to 1. But they specifically asked for senators to states, so the 2 has to come before the 1. So 2 over 1, 2 to 1, 2 to 1. So the order does matter based on what they asked for. Alright, so in this problem we have a scale model of a rectangular town has a length of 4 inches and a width of 9 inches. The width of the actual town is 300 feet. Find the length of the actual town. So we're given a length of 4 inches and a width of 9 inches. That's in the scale model. So in the actual town, so we need to make sure we match up length to width, length to width. So for length, we actually don't know that. That's what we want to find out. So we'll call that x. And then the width is 300 feet. Before we start, though, there's a problem. 300 feet here, but 4 inches and 9 inches here. In order to do this correctly, we need everything to be in the same measurement. So we need to change feet into inches. So how many inches are in a foot? 12. So let's multiply this number by 12. So we'll still get our 4 inches to 9 inches. And x over, and then 300 feet is actually 3,600 inches. So let's bring this down so there's more room. So now we want to cross multiply this proportion. So 9 times x will give us 9x, and then 4 times 3,600 is 14,400. So then to solve for x, we divide both sides by 9. And we'll get our final answer as x equals, which that would give us 1,600. And remember, we were in inches, so it's 1,600 inches. And if they wanted you to convert it to feet, you could then do that by dividing the whole thing by 12. But in this case, we can just have it inches. So our length of our actual town is 1,600 inches. And if they wanted it in feet, you could convert it, which would be 133 and a third feet. So it depends what they ask for an answer, but you will have to do some unit conversions. Alright, now time for the sponge activity. So, in problem number 1, we have 35 over 7 equals 25 over x, and I want you to solve for x. And in problem number 2, 3x minus 4 over 6 equals 28 over 21, and again I want you to solve for x. That's it for the lesson. Once again, please take notes on the entire lesson, rank yourself, do the sponge, submit it all to Google Classroom, and have a good night.